So what we're going to be looking at the mathematics of apportionment, and we're going to go on a little detour talking about more electoral college than anything else. But first things first, let's talk about there's math in politics and in America. You wouldn't think that there's a lot of math, but there's actually a cute little anecdote, a cute little story that goes along with some math that happened in American history that shows that now and politicians and people and government haven't been the greatest at math. Just showing. So the first thing is the state of Indiana. Oh, the state of Indiana, the crossroads of America. And back in 1897, Bill 246 came into the House and passed with flying colors. And basically what Bill 246 said was that if you whittled it down to one of the main things in it is that pi was exactly 3.2, not the irrational number that we all assume it is now, or we know it is. No, the state of Indiana was going to say that it was exactly 3.2, and it went in front of the House, passed the state of representatives. The state representatives in Indiana passed, went to the Senate, and it was tabled, and I don't think it was ever really shot down, but it's not going to pass. I think it's just kind of in that like purgatory state of bills in Indiana right now, and it's never going to be looked at again, and it's never going to pass. But the reason for this is because of one man, and this man's name is Edward J. Goodwin. Oh, Goodwin. And basically, Goodwin, as you see him pictured here, he decided he was an amateur mathematician. He was like, you know what? I just proved this. And he proved a problem called doubling the cube. And it was an ancient problem that many people were trying to see if they could prove or disprove. And it ended up being it's disproved. You can't do it. And he came about and he said, I did it! Woo! I did it. Now the problem is that he made, based on his answer, pi had to be 3.2. And the problem is that pi is not 3.2. Not even rounded correctly is at 3.2. And so what happened was after he brought it up, and he ended up saying, if you pass this, you guys can use this for free, this idea for free in all your schools in Indiana. But he was going to charge the other states that hadn't passed it. And that was kind of his idea, was to get it passed. If everybody would agree, if all the states passed it, they would be able to use it for free. And his idea was everywhere. But after it went through the representatives, luckily there was another man, a real mathematician by the name of Clarence A. Waldo, and he was sitting in there, heard this, thought it was ridiculous, and then when this bill went up in front of the state senate, he went up and he educated the senators and said, you know what, this is what it is. This is what pi is. It has to be 3.14. It can't be 2. It's this actual number. And after, apparently there's some discussion, but it was either shot down or it was tabled, and it's never going to be brought up again. And so, thanks to this man, one of the biggest heroes in American history that nobody knows about, saved American mathematics. Because, we could all be saying it's 3.2 now, but Mr. Waldo over here and his killer mustache saved us from that fateful day. And so, that's just a little history on, math and politics haven't gone well together. But before that, back in the 1700s, it went really well together. And the reason for that is because of the Electoral College. Now, you've probably heard about the Electoral College a lot. And basically, during presidential elections, everybody's like, oh, this state has this many votes, this state has this many votes, this state has this many votes. And what it is those are found mathematically. It's called apportionment. And what it is that if we have a collective number, a large number, and we want to divide it up evenly among a certain set of people or groups, in this case states, what we have to do is that we have to give it out evenly based on some sort of reasoning. And in this case, for the Electoral College, it's based on the population. The larger states get more votes. The smaller states get at least one vote. And that's what it is across the country. Now, this was decided based on math, okay? And the men behind this are the top two men were the first ones to really bring this up. Okay, Thomas Jefferson, our third president, Alexander Hamilton, the first head of the Treasury, were the first ones to bring this up. And basically, they were like, okay, this is the idea that we're going to have for dividing this up. Now, they had different ideas, and we all know they had one of the best relationships in politics. They were always best friends with each other, and no, not really, but so they were competing basically to see who could get theirs to be the one that's going to be used. And they're very similar. There's only a small difference. Thomas Jefferson's method favors the bigger states. Hamilton's tries to be more even across the way. And so, they had this competition. But they basically set up, apportionment, a method to divide it up evenly. And then after they had some problems with this a little bit later, a couple decades later, John Quincy Adams and Daniel Webster came up with their own methods. They're very similar, but there's small things that are different. Like Adams' method favors the smaller states. Webster's is very close to Hamilton's. And it's probably the most even all the way around out of these four. And so every 10 years, basically, the House of Representatives would vote for this is the one we're going to use, this is the one we're going to use, this is the one we're going to use, and then they would have those discussions on which method you can use, because based on different methods, different states get different number of votes. A larger state will get another electoral vote based on Thomas Jefferson's method than based on Hamilton's method. So the larger states would want to favor Jefferson's method. Smaller states would want Adams' method. So they always had those discussions every 10 years after the census. Well, now they don't have that anymore. There's a bill passed in the early 1900s that has just done away with that, and we'll discuss that later. Okay. But the problem is that with Hamilton's, there's some paradoxes that occurred. And basically the first paradox is called the Alabama paradox. Alabama, that state between Georgia and Mississippi. And basically the Alabama paradox is named after Alabama because Alabama was the main state when this paradox occurred in America. And it happened in about 1882. And what happened was they decided to increase the total number of seats, so they moved it up from from 99 seats to 100 seats. And what happened was Alabama ended up losing one of its seats because of the total increase of all the states. Alabama loses one of their seats, and Alabama was like, no, we want that seat for ourselves. And so even though they increased the overall total, Alabama still lost one of their seats. And obviously that doesn't make sense. It's not fair, and it shouldn't happen, but it happens. It's a paradox that happens in this. And so it happens. The next method that we had is called the population paradox. And one of the main things is Mississippi was Maine, not Mississippi, Maine. It's kind of happened to Maine a little bit. And basically what it was is if your state population increased faster than another state. So let's say North Carolina's state population increased 10%, and New Mexico state their population increased by 1%. Who do you think should get the extra seat if it's left over? Well, North Carolina. They got their population grew more. They should get the extra seat. But in some cases, no, that seat would go to North Carolina or New Mexico. Or North Carolina will lose one of its seats and it will be given to New Mexico. And that's just another paradox that occurs. All right, the last paradox that we had was the new state paradox. And basically what the new state paradox was is in 1907, Oklahoma gets added into the Union, and what happens is they just go, okay, Oklahoma, you should have had this many seats, so we're just going to give it to you and then just move on, not worry about anything else that's happening. Well, when they go around to the next apportionment and they actually calculate what it is, because they added in Oklahoma, what happened was that other states, their seats got moved around. So like New York actually had one of its seats moved over to Maine. So New York actually lost a seat because we added in Oklahoma. Now, by adding in another state, you don't think, oh, I add in here, I add another state in, but you over there, you lose one of yours. You have to give it to somebody else. Now, again, it's a paradox. It doesn't happen all the time, but it can happen, and it is a problem. And so that's why that it's one of those things that, it's a problem, and that's why we've moved away from the Hamilton method now on, and we have a new method that we use. All right, now a little detour onto what the Electoral College is, and maybe some fun facts that you had no idea about what the Electoral College was. So, the Electoral College is, you hear it, every 4 years with the elections. Oh, this person won this state, this person won this state. Well, on election night, the president actually doesn't. It's not official yet. About a month later, I believe it's usually in December, they actually cast the official Electoral College votes. And what happens is that every state basically nominates and puts up people. These are the people that are going to be voting these votes. So let's say, if we look at California, Obama won California back in 2012. And so what would have happened would have been the Democratic Party would have picked the 55 Obama supporters that they knew would always vote for Obama. They picked 55 of them to vote in the Electoral College for it. And they know this is going to happen, and it's no big deal. Now, these can be chosen either, it's somebody that could be working in the political party for a long time. It could be somebody that's really trusted, one of the friends of one of the people that work there. And some places even do like a convention where they actually nominate people to do this. And it's just different things, and usually they always vote for what it is. But the problem is that they're still not always binded to having to vote. They could actually vote for whoever they want. So on election night, it might say, President or candidate A actually won by 2 votes, or 2 electoral votes, 271 to 269, or 268, or 270 to 268. And what ends up happening is during the electoral vote, it might be switched. They might actually be even, or candidate B would have won. And that's because of something called faithless voters. And basically what faithless voters are, people that don't vote who they're supposed to, even though they've agreed they will vote for them, and people get upset with them because they're not supposed to do this. It doesn't happen a lot. It's happened actually 100 and some odd times in American history, but it's usually nothing big. It doesn't have a huge outcome on the overall election. Now, states have gone about trying to put laws in place making it illegal. So like Alaska, Hawaii, California, Nevada, Oregon, Washington, Montana, Wyoming, Colorado, Nebraska, New Mexico, Mississippi, Alabama, Florida, South Carolina, North Carolina, Virginia, Maryland, Vermont, Massachusetts, Connecticut, Rhode Island, Maine, Ohio, Michigan, and Wisconsin all have laws in place that basically will punish faithless voters. People that actually vote against who the state has elected will be punished. They could go to jail for this. And it's just one of those things that happens. And there's been 2 kind of weird cases in the past century. One was in 1972. Now, in 1972, Richard Milhouse Nixon, actually destroyed the Democratic candidate, won, 500 some electoral votes, easily won. Well, he won the state of Virginia. And the man that was supposed to cast one of these votes, this man in the middle right here, Roger McBride, decided, no, I'm not going to vote for Richard Nixon. This was before they had that law in place with the faithless voter. And he goes, nope, I'm going to vote for this man over here, the Libertarian candidate, John Hasburners. And that happened. It wasn't a big deal because the election wasn't close, but this is the last time that somebody's been a faithless voter and has actually voted for a different party candidate. Okay? And actually, Roger McBride ended up in 1976, ended up running for the presidency as a libertarian. Okay? But, I mean, that happened in 1976, or 1972. Kind of a cool little story that kind of happened. And, I mean, if it was a closer race, it might have had a bigger implication, but Nixon destroyed him. So, the last time that we had a faithless voter was actually in 2004. Minnesota went Democrat. It voted for Mr. Kerry. And at the time, Minnesota had like a unanimous or anonymous voting. so you don't know who you're voting for. And what they think happened was somebody voted actually for the wrong person. They voted for John Kerry's vice president candidate, John Edwards, for president. And so it was kind of like an oops moment. They don't know who it was. They weren't punished, but it's one of those things like, oh, oops, somebody actually did this. So I mean, that's the last time that we've had a faithless voter in the Electoral College. All right. So there's some cool stories, a little back on the Electoral College, and then next time we'll talk about more of the apportionment methods.